So we are going to replace this JK-Inverter BMS with this one. Welcome back to the Off-Grid Garage, my friends, here in sunny and hot Australia. Got beautiful weather. We just had a shower actually. It came down really hard, but now the sun is back and we have 168 amps outside, 8.8 going into the battery. Beautiful. And we've got another 112 kilowatts stored in the batteries anyway. Boom! Yes, brand new BMS from Gobel Power here, made by Pace exclusively for Gobel Power. And this one is a beast. Yeah, little size comparison to the JK-Inverter BMS. That's a lot longer and also wider. And of course higher as well. Is that good? Probably not. So let's have a quick look at the hardware first. So the first main thing here in the middle obviously is the current limiter. Yeah, this kicks in when the BMS goes into overcurrent either protection or alarm. And then it actively limits the current into the battery to 20 amps only. Here on the right we've got a bit of a heatsink situation, but actually it's not that big. Considering this is a 200 amp BMS, we've got only a fairly small heatsink for all these MOSFETs sitting underneath, and the same here on the back. And looking inside, the MOSFETs are only in this area here, and there's nothing here anymore. There you can see them as well. We've got two large resistors here to control the inrush current. And probably what you have noticed here on the left hand side, we don't have a passive balancer anymore. This new Gobel Power BMS comes with a 2 amp active balancer. And it uses these transformers and smaller capacitors. So it works a bit differently to the JK BMS and doesn't use any super caps anymore. The whole PCB has this conformal coating, back and front. We've got two M5 terminals here for the battery connection and two M5 connections for your inverter and load. And here you can also see the Pace logo, Pace AX. And what we have here is a P16S200A 51706. And it has a ton of connections here at the top and also at the bottom. So here at the top we still got the 4 ports for our balance cables, and they are still compatible with the JK connectors, so that's good. Then we've got a connector here for a 5 volt 12 light LED strip. I think this gives you a finer and more granular visibility on your state of charge of your battery. We then have a GPS connector, a 4-pin screen connector and a 5-pin screen connector. This port here is for a trip unit. And then we've got an RS232 to Wi-Fi and Bluetooth connector. So this BMS gets Wi-Fi and Bluetooth connection as well, via an external port and module. And here a few of you will be interested in, it has 2 heating pad ports. But here on this BMS, these ports are not soldered on. But this BMS hasn't got a real port for it, so I'm not sure if we can just solder on cables, but yet 2 different heating pad ports. Here at the bottom we've got the connector for the power button, a 2-pin connector for a current detector, and then we've got the usual connectors for the communication port for these 2 relays, floppy disk port for the CAN connection, RS485 and auto dial. So this new Gobel Power BMS here brings a ton of new features. Especially interesting is the Wi-Fi and Bluetooth connector, the 2 heating pads, auto dial, and some other connectors like the trip unit and the current detector. Unfortunately, at this point of time, I don't have any further information about these additional ports and if they are already functional or for future updates. Yeah, but so far the hardware for this new Gobel Power BMS. And it also comes with this old friend, the 4-button screen. You can see the shape of the PCB. It remembers a bit of a screen we have seen before, and it can replace existing displays from other Pace BMS. Yeah, there's just one connector here, and that's all. So, and then we've got the communication board, which looks identical to the JK comms board. But this one here again has some additional features. You can see we've got now 6 dip switches instead of 4, because this BMS can be paralleled with up to 64 of these BMSs together. And Gobel Power especially ensured that this BMS here is also working with their older generations of Pace BMSs. So I've tested this here in the Off-Grid Garage already with 2 other older BMSs, and it works a treat. All these BMSs work together in master-slave configuration. Obviously with the older BMS you can only address 16 BMS, while here with this new communication board and this BMS you can address up to 64 BMS. Let's have a look at the JK-Inverter BMS comms board. Yeah, we've got 4 connectors here and we've got 6 connectors here. So these ones are not really compatible anymore because of the amount of connectors and also the upgraded dip switches. And you may remember this connector here is an auto dial cable connector, which goes to the communication board as well and enables auto dialing. So you don't need the dip switches anymore to address your 64 BMS. It does it all automatically for you, which is fantastic. And it also comes with a whole bunch of cables, very, very long. 1 meter long balance cables. Yeah, cables to connect the communication board. This is our auto dial cable, positive for the battery. Yeah, just the usual stuff, you know. So let's have a look at the specifications of this BMS, what we can find. And I want to highlight some of the features to you. Parameter configuration. So basically all the parameters can be set by yourself. These are the default parameters you can see here. I don't want to go through all these parameter settings here and discuss them. Okay, these are the temperature alarms. Not too interesting. Current consumption smaller than 45 milliamps. In low power mode, it even takes less than 200 microamps. Wow. Balancing function 3.4 volts. It turns on, but you can change this setting. And I think the difference can be dialed down to only 20 or even 30 millivolt. And Gobel Power told me it doesn't make really sense to go lower because the voltage measurement accuracy at this point is not very high anyway. So balancing down to 10 or even 5 millivolt wouldn't make sense. We've got a full charge judgment if the battery voltage is over 55.2 volts and the current is lower than 5 amps. So features, so 16S battery. The static voltage sampling accuracy is smaller than 10 millivolt at room temperature. And the accuracy of the current measurement can reach less than 2% at, I think FS is full scale. But this would mean 200 amps and the accuracy is only 2%. That would mean an accuracy of 2 amps. That cannot be true. That would be really, really bad. Okay, we've got a 4-channel cell temperature detection and we can reach an accuracy of lower than 2 degrees Celsius at room temperature. Short circuit protection function with charging balance function. Supports cell capacity estimation function. I think this is what all BMSs do. They estimate the state of charge. Yeah, all the settings parameters can be set with the computer software. It has RS-232, 485 and CAN communication. Multiple sleep and wake up modes. Reset switch and automatic encoding, whatever that means. LCD display optional, charging current limit, buzzer, LED and other functions. Support online upgrade. Yeah, I have upgraded this one here once and this all can be done through the computer software, which we will have a look at after the specifications here. So here's a block diagram so you can roughly see how it works. Here we can see the charge current limiter here is bypassing the charge MOSFETs. So even if they turn off, we can still get some power into the battery through this charge current limiter. Okay, basic configuration. So let's have a look. Charge current limiter 20 amps, dry contacts, so they are hard coded. So we cannot specify when these 2 relays are coming on. Dry contact 1 normally open, closed during fault detection, and the second relay normally open, closed during low battery alarm. I think this was the same functionality with the other paste BMSs as well. Here it says heating film socket not soldered. Customer provides socket and solders it. Other hardware circuits remains. Okay, there's a heating turn on temperature and a heating turn off temperature. We will have a look at this later. And then I've got these nice words here. MCU external watchdog, dual total voltage detection and dual current detection. Sounds amazing, whatever that all means. Communication interface, parallel mode, RS485. This is for paralleling as usual to other BMSs. Upgrade mode, RS232. Active balancing maximum supports 2 amp. So here it says again, heating film socket on motherboard not soldered. Customer provides socket and solders it personally. It's very personally. Here it says modify active balancing strategy. Yeah, these are the conditions. Yeah, this is what I read before and I was a bit confused about this. Does not start if average voltage is larger 3.625 volts. So if the average of all your cells is over 3.62 volts, so fairly high, but still in the specifications of the cells, it does not balance anymore. Well, this is exactly when we need the balancer. Does not start if voltage difference is larger than 1 volt. Why not? It probably assumes there's a faulty cell in your pack and it doesn't start balancing anymore. Does not start balancing during high temperature alarms. That's cool. Does not start balancing during a fault. Alright. Okay, and that's pretty much... this is the explanation of all the LEDs here. Yeah, we're not going through this at the moment. Key description, sleeping, wake up, communication, CAN, RS485, 232, parallel, dip switches. Yeah, here are all the dip switches. So starting from 0 for the master, all the way up to 63 batteries. Yeah, and it says here when all the dip switches are on 0, it is set to parallel automatic encoding. But then you need this extra wire to connect the BMS to the communication board. Okay, interface description. Yep. Heating film connection, B positive, P negative. It looks like it is sitting in the positive path of your battery. Physical and dimension drawings. Yeah, you can see all the port descriptions here again in Chinese. Okay, communication board, display, screen, dimensions. Dimensions, you might be interested in that. Overall length, 350 millimeters. Close to 20 millimeters high. I don't know what the width of this BMS is. It doesn't say here in the drawing. Let's give it a quick measurement with its salt stock. There it is, 110 millimeters. This is for the 12 LED strip. Yeah, it gives you a more granular state of charge experience. All right, and this concludes the specifications document for this new Gobel Power BMS. Okay, I would say let me connect this BMS to our test battery here, and then we have a look at the app and see what kind of parameters we can actually set, change, and if this all makes sense. So that's a very easy and straightforward connection. Negative here, balance cables over here, positive over here with this crocodile cable gewirre. Communication board down here. We have the auto dial cable connected as well. Power button on the left hand side and the display on this side. Alright, let's see if it turns on. It does. That is always amazing. Okay, 53 volts. Let's see if we have all the cell voltages. 8, 12, 16, perfect. Capacity 65%, 280 ampere hours it says, remaining. So with this new Gobel Power BMS you can also set the CAN and RS485 communication protocol here directly on the screen. Victron, confirm, yes, protocol change, succeed. Very cool. Okay, what else can we set? Pylon, Schneider, Lux Power, SMA, Goodwies, Stutter. It's quite a few. Crowbot. What is Victron 23? And here RS485, Pace, Pylon Tech, Crowbot, Voltronic, Lux Power, wow, Pylon. That's it. System settings, baud rate 9600 and the version of the, don't know, BMS. Display. Alright, very basic, standard, and we have seen this before. Same here on the communication board. We've got two LEDs down here light up, so that's the 65%. We've got a green heartbeat light over here. No fault, nothing to see here. Alright, let's have a look at the application. This one needs to be downloaded, extracted, and then runs out of this folder wherever you extract it to, so there's no installation process as such. It's just an exe file with a lot of other files and I think an SQL database. So let's get this started. And I've also connected the RS232 2 USB adapter here to the computer. And here we can see already the Gobel Power BMS LV Tools 2.4. Go to comms, select my COM port, connect. And we get a confirmation down here, connected, protocol handshake, all good. We click on start and hopefully, yep, we got some data. Beautiful. So here at the top we have different tabs. And then we can see the battery info, voltage, current, state of charge, state of health, remaining capacity, full capacity, and the cycle count. Underneath here we've got a table with all the 16 cells and the voltage and if they are getting balanced. We are connected to pack number 1, address 48. I have put all the dip switches to 0. So obviously it negotiates the address with all the other batteries in parallel and you don't need to worry about any dip switches. So that is actually how it should be these days. Then we've got the temperature infos. All the 4 temperature sensors are here. MOSFET and ambient temperature as well. Cell maximum voltage, cell minimum voltage, and also the voltage difference and the temperature difference. Switch control. So we've got a manual control about the charge and discharge MOSFETs. We can select if the LEDs are on, the buzzer, and we can also put it to sleep. Here the communication port settings. And these are read-only. System status. Okay, this gives you only an indication what is going on at the moment. So we've got the charge and discharge MOSFETs turned on, but none of the other features are turned on or active. Then we've got warnings, protection, and fault status, and we've also got a password. I think it's 1, 2, 3, 4, 5, 6. Yep, everything turns green. And down here we've got the firmware status. Oh, okay, we have to upgrade this one here actually because this is still running 1.2. There's a 1.3 firmware version already available for this BMS. Again, it's the P16S200A. Okay, parallel, there's nothing to see because we've got only one BMS connected. History record, you can click on read record and then it should pull the information from the BMS onto the screen, which it does right now. Beautiful. Parameter settings, that's probably where we want to go. All right, here we are. These are the parameters. That looks quite different from the other PACE BMSs we have seen before, where you have an overload of parameters and settings. This looks much clearer, structured from the first glance. So let's read all the information first into these tables. Here it comes through. So cell over voltage, all the warnings, protections and recovery settings. Cell under voltage, the same. Pack over voltage and pack under voltage. How good is this structure, right? You don't need to go through a long list of settings and parameters to find everything. Making this in this table is very, very good. Then here we've got the temperature warnings, high discharge, high charge, low discharge, ambient. You can set your warnings, your protections and recovery again in a table format. And then unfortunately they changed to this structure here on the right hand side. So I'm not sure why they have not continued this table format and are now going into a different design. Yeah, now we've got the charge over current parameters. 3 of them, and they could have put this all in a table as well, like on this side. Now they go in the vertical structure again. Okay, so here we've got the charge over current warning. This is at the same time your CCL, your inverter max charge current, 145 amps. The protection kicks in at 210 amps. So you can set your CCL lower than your protection. That is very, very good. Thank you. We've got a delay timer. And then we've got battery parameters here. And by default, this sits on 55.2 volts. That is amazing. Pack fully charged voltage. And this is also your inverter maximum charge voltage, or CVL, the charge voltage limit in Victron. And it is also the state of charge reset voltage. But to reset the battery to 100%, you also have to meet the pack fully charged current. Yeah, 5 amps here. So a battery charges to 55.2, then your current goes down all the way to 5 amps or whatever you set. It absorbs, and then the BMS resets to 100% only. And this is the same mechanic as we have seen before with the PACE BMS. There's always a full charge voltage and a full charge current you can set to reset your BMS to 100%. So that's pretty good. Okay, then we've got a low state of charge warning in percentage. And this is also your inverter discharge limit state of charge. Yeah, if you reach 5% state of charge, it tells your inverter, hey, stop discharging. And if you are at 5% or above, it also enables the dynamic state of charge protection. And this is a feature, I talk about this a bit later, which you should definitely turn off. So you have to actually set this one here to 4%, because under 5% it disables this dynamic state of charge protection. It is kind of a good idea, but more about this later. Okay, then we've got the discharge overcurrent parameters. So we've got the discharge overcurrent warning, and this is also your inverter maximum discharge current, 155 amps, yeah? But we've got the protection of 210 amps again. Here's the warning, and the DCL is decoupled from your protection parameter. Very good, I like it. And then we've got a delay, and we've got another overcurrent protection of 250 amps. Okay, balance and sleep voltages. Balance start at 3.4 volts. I would not recommend starting that early. This is not in the steeper area of the curve. What am I typing? 3.45 it should be. Okay, and then we've got a passive balance start difference, yeah? A passive balance. So I've asked Gobel Power about this passive balancer, which is apparently here on this board, and I said, well, forget about this. This BMS does not have a passive balancer anymore, only active, and this is a relict from the old software, which still made it in the new version here for whatever reason. So we don't have a passive balancer, so this parameter here is actually without any functionality. We've got a sleep cell voltage, and we've got a sleep delay. So I think if the cells are under 3.15 volts for 5 minutes and there's no current going in and out, the BMS goes into sleep mode. Okay, let's write these parameters back to the BMS, whatever we have changed here. I think it was only 1 or 2 settings anyway. Yeah, so these are all the settings you can set in the new Gobel Power BMS, right? That is not very much. It is actually reduced by quite a lot from the old settings. And I really like this table structure here on the left. It is very clear to see what is going on and easy to find things. And then they changed the design of the software back here on the right hand side to a vertical. This is this Chinese inconsistency of making such a software. Okay, let's keep going here. System config. So this is very interesting. We can actually calibrate the voltage. We can calibrate the charge current and the discharge current separately, and we also have a current offset. So if your BMS constantly shows 1 or 2 amps too much, you can offset this one here with this parameters. But I'm not sure if we still need a calibration or even an offset for measuring the current through a BMS. Cell count, we can put in 16 and write this back to the BMS. We've got a charge limit, a start-up current. I think this is for the inrush current if you connect an inverter. So you can set actually a threshold here. And then you've got the intermittent charge limit, which you can set, but not see what the state is at the moment. There's no read function. Apparently this is a limitation of the communication to the BMS. So I'll tell you more about this intermittent charge limit in a second. And we've got the capacity, which we can read here. So this is 280 amp hours by default, and then you can set whatever capacity your battery has, and it makes an assumption about your state of charge. So this is only interesting for the very first setup, when you connect your battery for the very first time to this BMS. We can set some charge and discharge cycles here already if you have a battery which is already cycled. Product info, pack product info, you can put information in here and write them back to the BMS to identify it. Active balancing should be on. We've got a Gobel Power version, this is in here. And we've got the inverter protocol here again, which we can read, and it should have the Victron protocol, which we have set through the display already. Nice. There's again the list of all the supported inverters. And here the same for the RS485 protocol. Cool. All right. Communication, this is the communication RS232 back to the BMS. And we've got tools, so we can upgrade this BMS to a newer firmware. We can do this right now. Flashlight. There's nothing flashing. Okay, maybe this function doesn't work. Okay, browse for the bin file. Should be the one at the top here, 1.3, that's the one. Open it. The password. The password can be found in one of their documentations. There's the BMS password and also the upgrade password, 541800. and paste it in here. And yeah, it turns green. Okay, we've got the firmware file. Upgrade. In preparation, please wait. The upgrade is ready. Are you sure you want to upgrade? Yes. It does it. 5%. It takes a while. Alright, 95%. There's no animation or no sign of a firmware upgrade here. All the lights are normal. Oh, now it has turned off. Yep, because we are ready. Successful upgrade. That's what you want to hear. We can do a check, but we don't need to. So stop, clear, go out. Real-time monitor. See, it still shows the old version down here, but when we connect now, this should upgrade to 1.3. Start communicating. Yep, 1.3A it is. Can I have a look in the log file as well? The balance logic has updated as well. It is a bit complicated, a bit cumbersome to read this all and understand and make sense out of it. So here they talk about resting mode and also when the battery gets charged or discharged. And then you've got different conditions for the balancer to turn on than if the battery is actually charging or discharging. And also interesting here, they increase the delta for every 500 cycles of the battery by 1 millivolt. So they give the battery a bit more slack then basically, because when the cells are getting older, they may have a larger deviation, a larger delta across all the cells. Okay, maximum runtime per activation is 1 hour. After the activation, a 10-minute interval is required before restarting. If the current is smaller than 2 amps, it is considered resting. Right. So and then we've got the max request charge voltage logic. Yeah, 1 hour after fully charging, max request charge voltage is changed to PEC over voltage protection release value. Maximum request charge voltage is recovered to PEC full charge voltage value after state of charge drops to 95%. Does it make sense? Okay, let me explain. Because this is actually the full charging algorithm of this PACE BMS, yeah, which we have not had before unless you had upgraded your older PACE BMS to a newer firmware. Then you had this logic already as well. But unfortunately, neither PACE nor GobelPower are publishing newer firmwares for the BMS. So you really have to ask GobelPower to send you the newest firmware for your BMS. But if you don't know if there's a new version or not, you cannot constantly ask them. Yeah, we know exactly that some manufacturers of these BMS, they treat new firmware versions like a secret, and they're not making this public. And over time, these new firmware versions, they leak through forums and everything into the public and get shared over there. But man, come on, this is one of the biggest features of these BMSs. So why not advertise it and take full benefit out of it? I don't understand why they keep this secret. Anyway, we are 130 now, and we go back into the parameter settings, yeah? Okay, what is going to happen is we are charging to 55.2 volts, yeah? If the current goes under 5 amps, then the BMS resets to 100%. And then the battery stays there for exactly 1 hour. That's what it says down there in the text. 1 hour after fully charging. Yeah, it keeps the 55.2 volts. And this is for a very good reason, because fully absorbing the battery and also balancing. Yeah, we need this elevated voltage for the balancing. So after 1 hour, this 55.2 volts will be lowered to the PEC over voltage protection release. So after this 1 hour, 55.2 volts goes down to 54.4 volts. And of course you can change this here to 53.6 volts, yeah? Because this is just a recovery voltage, it doesn't do anything. But this is also your float voltage here for this BMS. I'm not sure why they have not just got another parameter here, another setting here where it says, well, after 1 hour it goes down to this voltage and you can set this separately from the recovery voltage, but no, it is the recovery voltage, whatever. So 55.2 volts for 1 hour, that's a fixed balance and absorption time. And afterwards we're going down now to 53.6. For how long? When does it go into rebulk? Yeah, when does it start rebulking your battery, recharging? And this is exactly where the other parameter comes into play, which is on another page under system configuration. This is your intermittent charging limit. because here you can set everything between 75% and 96%. Yeah, 96% is the highest. So if I set this one here to 90%, for example, yeah, and write this back, I'm overwriting the existing parameter, which I don't know what it was before. So I need to write this down on a piece of paper and keep this note somewhere safe, because apparently the BMS protocol cannot read this parameter and display it here in the software. So 90% we have set as the intercharge limit, yeah? So go back to the parameters. So it would now stay on 53.6 volts float voltage until the battery goes down under 90% state of charge. So this is a very similar algorithm now, mechanic, as we have in the JK-Inverter BMS. But there we can set all the parameters separately, individually, and it is a bit clearer what it actually does. Here it is all very hidden, yeah? There's no additional text here in the software where it says, hey, this recovery voltage is also your float voltage. And once the BMS has reset, we are staying there at 55.2 volts for 1 hour. Doesn't say anywhere here, anywhere. Yeah, and this is basically what this text down here means, yeah? 1 hour after fully charging, 55.2 volts and less than 5 amps. Charge voltage is changed to pack over voltage protection release. That is this one here. That's what we have done, yeah? And then maximum request charge voltage is recovered. That means it goes back from 53.6 to 55.2. After state of charge drops to 95%, probably the default setting. We have set it to 90% now. And this actually makes a pretty good charging algorithm already, yeah? With absorption, with float, with rebulk, everything is there we need. So it's almost perfect, but it is also very hidden. Okay, let me have a look in my documentation here. So you may have seen that we cannot set any balance delta voltage at all, yeah? We can only set a start voltage of 3.45 we want. Write this back. And the passive balancing start difference doesn't exist anymore. This is for sleeping. So there's no active, so there's no cell delta voltage you can set for the balancer to reach. Because this delta is dynamic, as we have seen here in this documentation, yeah? Here, static turn on, yeah? I don't know what Gmax is. What is Gmax? Well, anyway, if Gmax is larger than the turn on voltage with a 3.45 volts and the voltage difference is larger than 30 millivolt, turn on the active balancer. When you charge and discharge, it is different. It says Gmax is larger than the 3.45 volts and the voltage difference needs to be 50 millivolt, because when you charge and discharge, you automatically have a larger cell delta, yeah? That is true. So this is a bit dynamic what they are doing here. If this makes sense, or if this makes a difference in balancing your battery, I doubt it. So this whole chapter here, this whole paragraph, they could get rid of all this code inside their algorithm and just offer the customer to put in a number between 5 millivolt and 50 millivolt, for example. And then it would be crystal clear how the balancer works, yeah? So here we've got a dynamic balancer. It's a feature, not a bug. Ah yeah, you will see this in the next video when we actually do see how the battery works. So this is a 2 amp active balancer, but it balances only with 1 amp for cell 1 to 8 and another 1 amp for cell 9 to 16. So the battery is basically split into 2 groups, yeah, 1 to 8 and 9 to 16, and each of them has got a 1 amp active balancer. The balancer runs for 1 minute. It gets the energy from the highest cell in this group into the balancer, into the caps, and then from there back into the cell with the lowest voltage. But technically, it is only a 1 amp active balancer per group. It is not discharging your cell with 2 amps, only 1 amp, but it does it on 2 separate individual cells at the same time. So hence, they're saying we've got a 2 amp active balancer. It's a bit of a marketing trick, but okay. Yeah, I could actually measure the 1 amp. We will see this in the next video then. I think this is all which matters at the moment. Ah, no. There is another feature which I have hinted on, which is called the Dynamic State of Charge Protection. So the thinking about this is actually pretty good. Usually in wintertime, what happens is you discharge your battery and the battery goes down to like 5 or 10%. Yeah, you recharge your battery a little bit over the daytime, but there's not enough sun to fully charge it, of course. So you probably get to 20-25%, and then sun goes down, you use this 20% again until the next morning. So you're cycling your battery in the very bottom of the battery all the time and never fully charge it because you're using this charge energy all the time. So the idea is now to charge your battery with this 20-25% and then don't use this energy at night. Yeah, they are setting DCL to 0, so telling your inverter don't use any energy from the battery. The next day you're charging another 20% on top, yeah, brings the battery to 40%. And you can already see where this leads to, yeah. You're only charging the battery every single day until it hits 100% state of charge. Then it all resets, top balances and everything, and then the inverter can take the energy and use it all up until the battery goes down to 5%, and then this whole dynamic state of charge protection starts again. Yeah. So it is actually a pretty good idea, especially if you have a long winter and you're not fully charging your battery. And Gobel Power advertises this as you're not wasting energy here because you're not using the energy, you're storing it and using it later, which is exactly right. Yeah, you're filling up your battery every single day, whatever the solar brings, until it's 100%, and then you use all this stored energy from the last 5 or 7 or 10 days or whatever it is, all at once. Yeah, so you're using the energy, but later. So that's fine. The only problem here is the DCL 0 would mean, for me as an off-grid installation person, DCL 0 turns off my inverter. And I would lose all the power. Yeah, regardless what the battery has, I would lose all the power. In an off-grid situation, you cannot set DCL to 0. You can set it to 1 amp, and the inverter would still take whatever it needs to cover the load. Yeah, it doesn't really follow DCL here in an off-grid situation because the battery is the only energy source it has. It cannot take only 10 amps from the battery and 40 amps from the grid. There is no grid. Yeah, it can only take everything from the battery as long as DCL is not 0. So even if it sits on 1 amp, I can take whatever I need. It doesn't matter. But if it sits on 0, it signals to the inverter, hey, there's something wrong with the battery. It is totally depleted. DCL is on 0, turn off. Not good. And exactly the same happens for everyone else with hybrid inverters, which have grid connection and the battery. Yeah, if your DCL is on 0, the inverter would not take any juice from the battery. It would take everything from the grid. What if your grid is failing? Yeah, your battery has recovered through this dynamic state of charge protection to like 60-70%, and your grid fails. Your inverter will get a signal from the battery, from the BMS, DCL 0, and you will be in the same off-grid situation as well. No grid, DCL is 0, inverter turns off, but your battery is on 70% state of charge and you will not be able to use this energy. So as good as this idea is, it doesn't work in real life, neither for me nor for everyone else. So what you have to do is you have to really change this to 4%, because it says below 5% it disables this dynamic state of charge protection. Unfortunately, we have to set this to 4%. I cannot have DCL 0, and everyone else shouldn't have DCL 0 either, because if the grid fails, you are in the dark. So this is probably the first time they're introducing such an idea to a charging or to a BMS algorithm, which, as I said, is not bad, but the actual mechanic doesn't really work. So, okay, that is this, yeah. They said again the current accuracy can reach smaller or equal 2% of full scale FS. So this is FS means full scale. But full scale is 200 amps. And 2%, that is 1% is 2 amps, that is 4 amps. 4 amps accuracy. That cannot be true. That would be insane. That would be a friggin' nightmare. They also said at normal ambient temperature, the static voltage sampling accuracy can reach smaller 10 millivolt. This is why the voltage difference below 20 millivolt may be meaningless. Yeah, you can see it here. Pretty much the balancing condition description, 20 millivolt is the best of balancing we can get from this BMS. 20, 30, 40 or 50 depending on the conditions, if we charge or not, or if it is in idle mode, so to speak. So 20 millivolt. And I asked, can we not get 5 or 10 millivolt? And they said, well, it wouldn't make sense because the measuring accuracy of the BMS is not good enough to make use out of 5 or 10 millivolts. So if this is true or not, I don't know. I mean, at the end, 20 millivolt is fine. But I would rather see another setting in here where the customer, the user, can actually put in, I want to balance to 10 millivolt, and that's it. Yeah, so I've got the assurance 10 millivolt, it will be regardless if it's idling or charging, discharging, doesn't matter. So there you have it. I think this is all the BMS can give us at the moment. There's also tools, which is the BMS Upgrade, and the languages, which can be also in Deutsch or in Espanol. So you can see they're going into the right direction. They've got the full charging algorithm now included here with rebulk at a certain state of charge of your battery. You can set a charge voltage independent of the protection voltage. It does a float voltage, which is the same value as the pack over voltage recovery. We've got a dynamic balancing functionality, so you may end up with a 50 millivolt accuracy in your balancing. And you wonder why the BMS is not balancing even further. And of course, we've got this good idea of the dynamic state of charge protection, but it's not really working for anyone. Yeah, all right, my friends. I think so far this video for today, I'm introducing the new Gobel Power BMS. Is this a real competitor to the JK-Inverter BMS? I think we still have a bit clearer settings and parameters for the JK-Inverter BMS. We can also freely program these two relays on the JK-Inverter BMS and set state of charge, under voltage, over voltage, temperatures as the trigger point for these relays. And then start heating pads, generators, cooling, whatever. While in the Gobel Power BMS, these two relays are hardwired to alarm and under voltage, under state of charge protection or something. I must say the charging algorithm is very similar between the JK-Inverter BMS and the new Gobel Power BMS. The setup though is a bit more complicated in the Gobel Power. It needs a bit more thinking and carefully setting the parameters correctly, while in the JK it is far more intuitive to get this all right and up and running. So yeah, at this point, I'm not sure if this is a runner-up or if it is now the king of the inverter BMS. One interesting feature of this BMS though is not only the Bluetooth and Wi-Fi capability, but also it can connect to this device, which is a Waveshare RS232 to Ethernet server. So you connect the RS232 ports of your BMS to this device, and this one plugs into your local network. This means all the data of the BMS is now on the network. And Gobel Power has actually developed their own Home Assistant integration, and Home Assistant just grabs all the information from the network and shows them on the dashboard. So we will have a look at this in a future video as well. There's a bit of a setup necessary to get this all working with these servers here, because the BMS has now Wi-Fi connection. You can also use this Wi-Fi connection to put all the information, all the data onto the network, and you don't need to hardwire anything anymore. But you've got both options. You can hardwire it if you don't like Wi-Fi, if you don't have Wi-Fi in this location, or you can use Wi-Fi and get the same information into Home Assistant onto your network. Yeah, and as you may remember from one of the last videos, we have upgraded or downgraded, changed this BMS here, which was a Zeppler's BMS, then it was a JK-Inverter BMS, and now it is the new Gobel Power BMS battery. Yeah, 6 dip switches here. And in the next video, we want to see how this charging algorithm works, if it works, what it does, and how it looks like. Can it balance the battery? Well, we will find out. So pretty interesting BMS testing is coming up here on the channel, but for today, introduction of the Gobel Power BMS here, made by Pace exclusively for them. 2 amp active balancer, charging algorithm, Wi-Fi, Bluetooth. Unfortunately, they didn't send me the Wi-Fi module for it. So as soon as this comes out, I will show you here on the channel, of course. And you can see where the journey goes with all these BMSs now. Yeah, this is all networked together, either via cable or Wi-Fi, and accessible from everywhere. Home assistant integration and control to maximize charging, discharging, and the usage of your battery then. So pretty cool stuff. At the moment, it looks like they are only selling this BMS together with a do-it-yourself box. It is not for sale as a standalone BMS, so you cannot buy this BMS separately without a box, which is a bit of a downer. But maybe if enough people ask, they will separate this from the box and you can just buy the BMS if you want to upgrade yours. But also be aware that the mounting points of the JK-Inverter BMS or the old Pace BMS are not the same anymore to the new BMS, yeah? You can see it is much longer, it is much wider, it is higher as well. So it is not an easy drop-in replacement anymore as it was before, unfortunately. There's a bit of do-it-yourself work necessary, or a big plastic bag maybe. That worked for me as well. So yeah, my friends, leave your comments down below. What do you think about the new Gobel Power BMS? Is this good progress? Is this a competitor to the existing JK-Inverter BMS? Would you consider replacing your JK-Inverter BMS with this new Gobel Power BMS? Or if you are in the market to buy new batteries, would you consider this Gobel Power BMS rather than a DALI, a JBD, or the JK-Inverter BMS? So leave your comments down below. Always keen to read it. Very good information in there. Helps out you, helps out me, helps out everyone in the community. So thank you very much. Alright, my friends, thank you very much for your support here. More videos are coming soon. Leave a nice comment down under the video if you are new here, subscribe. Hit the like button if you enjoy this sort of content. And until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye.